Okay, so sorry about putting the video a little bit late today, but I want to go ahead and do System of Elimination Part 2. This is a little more complicated, so make sure you're taking good notes with this. If you have the notes I gave you today, these will follow along with the examples in your notes. So just even though it's not going to look quite the same, it'll follow along. Okay, so let's just jump right in. So again, the solution of a system, just to review, is where two functions intersect, or two linear functions intersect, so that's an intersecting point. So what we're looking for is an ordered pair, an x and y coordinate. And again, it's a way for us to solve two unknown variables a little bit easier. Okay? And again, for the elimination, the goal is to eliminate one of the variables and solve for the other. And we want to use elimination when our problems are set up into standard form or something similar to standard form. But you can use elimination whenever you want, but the best optimal time to use elimination is when they're in standard form. Okay, so here we go. Let's just jump right in. Example number 1. And it's right there on your page. Example number 1 is 2x minus 3y is equal to 4. X plus 4y is equal to negative 9. And right off the bat, we're going to find out where our difference is from what we learned last Thursday and what we reviewed on today and what we're doing today, because there's going to be a significant change here. All right, first thing I want to do is I want to look. Do 2x and x cancel out? No. What about negative 3y and 4? Do they cancel out? No. Okay, now, before when we said no to both answers, we were able just to multiply by negative 1, and that would have solved the problem. Now look here, if I multiply anything by negative 1, is that going to allow me to cancel out? Okay, and I'm just going to kind of show you the wrong way over here just so you can kind of see it. So if I multiply negative 2x minus 3y, what does it become? Negative 2x plus 3y equals negative 4. And then I just bring down the x plus 4y is equal to negative 9. Does anything cancel out here? Is there anything that will cancel out? No, that doesn't work either, right? Okay, so nothing cancels out because I still have here, I have negative x plus 7y is equal to negative 13. So that doesn't work for us. Okay, if I multiply the bottom one, I would have 2x minus 3y is equal to 4. Multiplying the bottom one by negative 1 to give me negative x minus 4y is equal to 9, right? If you look here, in this case I have x minus 7y is equal to 13. Did I cancel anything out there? No, I did not. Okay, so that doesn't work. So obviously I've got to do something a little bit more than just multiplying by a negative 1. So in this case, I've got to look and see what else I can multiply and add to that in order to eliminate the variable. Okay, so again, our goal is still to eliminate x or y. Now, here's one of the keys, or a hint, if you will. Look for a positive and negative variable. Okay, so in this case, you'll see right here, I have a negative y and a positive y. If I look for that, that allows me to only have to multiply by a positive number. Okay, so what I'm going to do is this. I'm going to multiply them by each other. Okay, what I mean by that is this. I'm going to multiply this one up here by 4. And that's going to give me 4 times 2x is 8x. 4 times negative 3 is negative 12y. 4 times 4 is 16. What do you think I'm going to multiply this one down here by? And again, I'm focusing on my y's. What's going to give me a positive y, that 12y value? Yeah, multiplying by a 3. And like I said, if there's a positive and negative already, like I said over here, okay, then you only have to multiply these numbers by positive numbers. Okay, so then I'll multiply 3 times x is 3x. 3 times 4y is positive 12y. 3 times negative 9 is negative 27. Now I have a system of equations I can work with using elimination. Okay, so now it becomes, again, a big addition problem. So add these together. 8 plus 3x is 11x. Negative 12 plus 12 cancels. Bring down your equals. And then you have 16 minus 27 is negative 11. Solve for x now. Divide both sides by 11. And x is equal to negative 1 when you simplify. I'm not done there. If you remember before, now I've got to find my y value. And again, remember, here's another hint. You have to plug back into an original equation. Because I have two new equations, right? But I've got to take this negative 1 and plug it into one of these, whichever I feel is easiest. I'm going to go ahead and I'm going to plug it into the bottom one because I feel like that's easier. So I'm going to put negative 1 plus 4y is equal to negative 9. Go ahead and solve this. I add 1 to both sides. That's going to cancel out, leave me with 4y is equal to negative 8. I'm going to move this up here so I have a little more room. So 4y is equal to negative 8. Divide both sides by 4. So y is equal to negative 2. So then my solution is negative 1 comma negative 2. And remember we talked quickly today or in class today about checking my answers. I could check my answers by plugging these back into the original equation and making sure they balance. Okay? And that's pretty much our new way, our new addition. That's how it gets a little more difficult. And if you're a little nervous right now or you're confused right now, just bear with it. Let's take a look at a couple more examples and just keep following along with the examples. The one thing I can't encourage you enough to do is if you don't understand something, don't quit. Don't give up because I don't get it after the first example. You're not always going to get it after the first example. So keep going, keep following along with these examples, and then hopefully eventually it'll click in. And then make sure if you have any questions, write down your questions, bring them to class with you, okay, and ask them in class. All right, so let's look at our next example. Okay, example 2. We're going to have 4x. Actually, let me give me some more space there so it doesn't look like that's part of the problem. 4x minus 5y is equal to 23. 3x plus 10y is equal to 31. Again, if you remember the hint that I gave you on the last example, you want to look for a positive and a negative y right off the bat. If there's one that's out there for you, take it. Again, you'll see it right here. There's a positive and a negative. I just said y. It doesn't have to be a y. But a positive and a negative variable. You want to look for that right away. Okay? So we have one there. How can I make these two look like each other? Because again, go through your check process. Do 4 and 3 cancel? No. Do negative 5 and 10 cancel? No. It doesn't matter about these. That doesn't make any difference. So let's go ahead and how can I make these two look like each other? Well, luckily, we only have to do it to one thing here. Let's start by multiplying this by, what can I make that to look like 2, right? I don't have to multiply by 10 because if I multiply this by 2, look what's going to happen. 2 times 4 is 8x. 2 times negative 5 is negative 10y. 2 times 23 is going to be 46. Now, will this negative 10y right here cancel with that positive 10y? Yeah. It sure will. So this is a little bit easier than the first example. So we don't have to multiply. So all I have to do now is bring that one down. And now I have 3x plus 10y is equal to 31. Now I can solve this. Again, a big addition problem. 8 plus 3 is 11x. Apparently that's popular. Okay. Then you have positive and negative 10y's cancel out. Bring down your equals. 46 and 31 is 77. Divide both sides by 11. That cancels. X is equal to 77 divided by 11 is 7. Okay? Now we need to find our Y value. So we're going to take this, plug it back into one of the originals. Since I haven't manipulated the bottom one at all and all the numbers are positive, I'm just going to use the bottom one. Okay? So I'm going to take 3 times 7 plus 10y is equal to 31. 3 times 7 is 21 plus 10y is equal to 31. Subtract 21 from both sides. That's going to give me 10y is equal to 10. I'm running out of room, so I'm going to move it up here. 10y is equal to 10. Divide both sides by 10. That cancels, leaving me with y equals 1. Okay, so now I have my solution. My solution is x. Sorry, I don't want to write it that way. I want to write it like an ordered pair. So I have 7, 1. There's my solution. And again, if I wanted to check, I could check that answer. Again, always write down any questions that you might have as we go through this, because I know that you can't ask me questions now, but write them down so you can ask me tomorrow if need be. All right, let's look at a couple more examples. Okay, example 3. We have 3a plus 4c is equal to 2. 5a plus 9c is equal to 1. Now, you can do this one of two ways, okay? I'm going to show you a new way here where we're going to do subtraction. I don't recommend this because I feel like once students get the hang of addition, you can stick with that. But we can call this subtraction. What I can do now is, first thing I want to do like normal is look for any matches. Can 3 and 5 cancel? No. Can 4 and 9 cancel? No. Now I need to look. Are there a positive and negative variable? Well, positive A, positive C, positive C. So there's no positive and negative. So what I can do is, instead of multiplying by a negative, I can just make one of these two sets of variables look the same. I'm going to go ahead and go with A. I'm going to make A's look the same. So how do I make 3A match with 5A? Well, the easiest thing to do if you don't know right off the bat, just multiply by 5. So I'm going to multiply by 5. Now here I have 5 times 3A is 15A. 5 times 4 is 20C. 5 times 2 is 10. Okay, now, will any of these in this column match what I just did? Do I have a 15A in that column or a 20C? I do not, so I need to multiply the bottom by something. Well, I've started with the A's, so I'm going to multiply by 3 in this case. 3 times 5 is 15A. 3 times 9 is 27C. And 3 times 1 is 3. Now, if you notice here, I do not have a matching set. Okay? I do not have a matching, an opposite set. So 15 and 15 don't cancel. 20 and 27 don't cancel. So how could I cancel those? Well, if I use subtraction, I can cancel. I've been telling you to use a big addition problem, and I'm going to keep telling you that only because, again, I'm not a big fan of subtraction. I'm not a big fan of jumping back and forth from addition to subtraction. You can if you want to, but I'm not a big fan. I'm going to show you the subtraction problem this time, and then I'm not going to do it again probably at all. Okay, so here's what I can do. I can subtract instead. So I can do 15 minus 15 cancels, right? Now that I'd have to go 20 minus 27. Well, 20 minus 27 is negative 7. C. And then 10 minus 3 is 7. So I subtracted all those instead of added all those, which works equally the same as addition, except you got to remember when to use it, when not to use it. So now I solve for C. I'm going to have negative 7 divided by negative 7 divided on both sides, and C is equal to negative 1. I want to go ahead and take this back and put it in one of my original equations. And this is the same as what we've been doing, okay? So here I'm going to do 3a plus 4 times negative 1 equals 2. So then I have 3a plus, minus, because 4 times negative 1 is negative 4, minus 4 is equal to 2. Add 4 to both sides. Then I have 3a is equal to 6. Divide both sides by 3. That cancels. Come up here. A is equal to 6 over 3. A is equal to, when I reduce it, to 2. Okay, and whenever I do these, I have to go in alphabetical order. So my ordered pair is going to be A, comma, C. So in this case, it's going to be 2, comma, negative 1. Okay, and again, I use subtraction for that one. I won't use subtraction again for the rest. I'm going to do it just with addition, because I don't like to keep changing back and forth between addition and subtraction. I don't like to teach it that way either. But you can do subtraction. This is your one example to show you how you can do both. Okay? Alright, so let's look at another example. 2 more examples and then we're done. I just want to make sure you have enough examples to really help you understand. So example 4, right out of your notes. 4p minus 5q is equal to 3. 12p minus 15q is equal to 9. So let's take a look. Does 4 and 12 cancel? No. Do negative 5 and negative 15 cancel? No. Okay? So now, do I have an opposite pair? Do I have 2 variables with different signs? Now I have positive p, negative p, right? I'm sorry, negative q. Okay, so here's the deal. If that's the case, instead of using subtraction, what you can do here is you're going to multiply by a negative, okay? So let's say I want to get rid of the p's. I need to make 4p look like 12p. Can I do that? Yeah, if I multiply by 3 times 4 is going to be 12p, right? But I need it to be negative so they cancel out if I'm going to use addition. So I'm going to multiply by negative 3. So negative 3 times 4 is negative 12p. Negative 3 times negative 5 is positive 15q. Negative 3 times positive 3 is negative 9. Now, will these cancel right here? Will 12 and 12 cancel? Absolutely, because this one's negative, so they'll cancel. So just go ahead and bring this down, and now you have 12p minus 15q equals 9. Some of you might have already figured out where this problem's going. Look what's going to happen here. Negative 12 plus 12 cancels. Positive 15 minus 15 cancels, leaving me with 0 over here. Over here I have negative 9. And positive 9 cancel, leaving me with 0 here. Okay? If this works out this way, it's a good thing. Because 1, you're done. You don't have to do any more work. And your answer is simply, and you have to do this by memorization. Does this make sense? 0 equals 0? Yeah. So the answer is infinitely many solutions. Or again, you could do all real numbers. And that would be, wow, not that. And that would be your solution to that problem. Okay? Please, again, as always, write down any questions. And again, notice I did addition here because I multiplied by a negative. Multiplying by that negative creates my addition problem. All right, last example. Okay? Example 5, again, straight out of your notes that you have, that notes page. Okay? We have negative 2m plus 5n is equal to 2. 4m minus 10n is equal to 12. Okay? Do I have a matching pair? 2m, does that cancel out with 4m? No. 5 and 10? No. Okay. So I need to multiply, and I usually just start at the top by multiplying the top. So I need to multiply something up here to cancel. Well, if I want to go ahead and just do the first one, I can cancel the 4. Look, it's opposite pair, right? So all I have to do is multiply by a positive here because I have a positive and a negative already. So 2 times negative 2 is negative 4m. 2 times 5 is positive 10n. 2 times 2 is 4. Now, will these cancel right there? Absolutely. So you just got to bring it down. And now you have 4m minus 10n is equal to 12. So here's my new solution, my new system. So negative 4 and positive 4, those cancel. 10 and negative 10 cancel, leaving me with 0 over here. Equals 4 plus 12 is 16. 0 does not equal 16, so that doesn't make sense. If it doesn't make sense, then your answer becomes no solution. Okay, or again, that sign right there. It's called an empty set. And that's it. Okay, a little more complicated. You just have to pay attention to what you're multiplying. Again, your ultimate goal is by this step right here, okay, this section right here, that you're able to cancel out something. In this case, we were able to cancel out both those things, okay? If you can't cancel out something there, you need to go back and revisit what you multiplied to see if you multiplied right. Okay, if you have any questions, please feel free to write them down, bring them to me in tutoring in the morning, or you can ask them during class. Other than that, you guys have a great night. I'll see you at the regular time tomorrow morning.